and today we are going to discuss chapter number 18, nuclear physics, and the topic of our discussion is radioactivity. You know, radioactivity is that process in which an unstable nucleus releases some energy in form of subatomic particles in form of some rays to get stability. That process in which an unstable element releases energy in form of subatomic particles or in form of gamma rays to attain stability known as radioactivity. You know, subatomic particles are what? Subatomic particles can be electron, proton and neutrons, and gamma rays also showing you some in form of energy. Okay, gamma rays are in form of energy. We'll discuss in detail. Okay, so spontaneous release of subatomic particles or gamma rays by unstable elements, after that they form new nuclei, and to attain stability the radioactivity phenomena take place. Okay, so we can say that spontaneous release of subatomic particles or gamma rays by unstable atoms as their nuclei tend to break into other particles to attain stability is known as radioactivity. Now, what are radioactive elements? All those elements whose atomic number is greater than 82, they will be considered as radioactive elements. All those elements whose atomic number is greater than 82, they will be considered as radioactive elements, and they are highly unstable. To attain stability, they do what? They perform radioactivity phenomena, or you may say process. Now, radioactive elements are of two types: natural radioactive elements and artificial radioactive elements. Natural radioactive elements are those elements whose atomic numbers are already greater than 82. For example, uranium, thorium, polonium, radium, radon, etc. These are natural radioactive elements. And what are artificial radioactive elements? Artificial radioactive elements are those elements which are not radioactive, but we make them radioactive by making them unstable, by falling energy on it, by giving temperature to it, by providing some external source of energy to them. We make them unstable. When they become unstable, automatically they releases some energy from them to get stability. So those elements are called artificial radioactive elements. For example, it includes sulfur, nitrogen, phosphorus, carbon, and a lot more. Okay, now we discuss experimental work. Okay, if we place a radioactive sample, for example radon, in electric field, what kind of behavior it shows? If we place a radioactive sample in magnetic field, what kind of behavior it shows? Now look, for example, we are discussing radioactive sample. We have taken radon in magnetic field. We have taken radon in magnetic field. Okay, look, we have taken radioactive sample over here like this. This is a lead container in which we have taken a radioactive sample. For example, we have taken a radioactive sample over here. That radioactive sample is radon, Rn. Radioactive sample. Okay, now magnetic field is provided. This magnetic field is into the page over here like this. Okay, magnetic field over here is into the page, into the paper, or you may say into the page. Now this is, we are having a screen, or you may say fluorescent screen you can take, or any other screen which can detect these particles, right? Okay, this is what photographic plate. This is photographic plate. Okay, and this whole chamber is enclosed in a box. Okay, and this is lead cylinder. Okay, now what happens? Look, we have observed that alpha particles will move at the top over here like this, this unstable element will release some energy in form of gamma rays and in form of alpha, beta and gamma rays and in form of some subatomic particles. So we have observed that there will be a particle or a particle which is moving upward. We will call that alpha particle. It is represented by this symbol. This is what? Alpha. And another ray will come, another particle will come and it will move down. It will be showing as beta. Its symbol is this. Beta. And there is third ray or third particle, not a particle but array, what we call gamma ray. It will show you no deviation. It will come very straight over here like this. This is what? This is gamma. Okay, this is what? This is gamma. Now, this was whole evacuated chamber. Okay. This was what? This was evacuated chamber. Okay, now coming, this was radioactive sample in magnetic field. Now we are discussing the same radioactive sample in electric field. Radioactive sample in electric field. Okay, the same radioactive sample we are having and we are discussing in electric field. Now we can edit it. Look. Radioactive sample in electric field. Okay, the same type of setup we are having, and now we are placing two plates parallel to each other. First plate is negative plate and other plate is positive plate, right? In between we are having an electric field. In between we are having what? Electric field over here. In between these two plates we are having electric field. And the same radioactive sample, what we call radon, is placed over here. And we will observe that the same three type of rays will come, or you can say particles will come and it will strike the photographic plate, or you may say screen. The first, it will move up, okay, and it will be called as what? It will be called as alpha. And second will move down over here like this, and it will show you beta. And third will show you no deviation. This is what we call gamma. It is represented by this sample. Okay, so we have discussed radioactive sample in electric field and we have discussed radioactive sample in magnetic field. Okay, now coming towards nature of emission, like what is nature of emission of these particles, like what is alpha, what is beta and what is gamma. So we are going to discuss it in detail over here. Okay, now I'm erasing this side. Nature of emission of alpha, beta and gamma. Nature of emissions, first for alpha emission. You know, alpha is basically the nucleus of helium, or you can say the nuclei of helium. Alpha is represented by this symbol. Alpha is doubly positive charge, right? As helium atomic number is 2 and atomic mass is 4. Okay, alpha is what they are, helium nucleus. Alpha has doubly positive charge. Okay, now what is beta, or what is beta emission? Now let me discuss an example over here. For example, if from an element alpha is released, look, for example, we are having X an element, right? And it has atomic number Z and atomic mass A. If it releases alpha, new element will form, and the atomic number of that new element